In this lecture, we will discuss a theorem of real analysis which tells us that when f is differentiable on closed interval a comma b and we have a number lambda which lies between f dash a, since f is differentiable we can have f dash a, then if lambda is a number which lies between f dash a and f dash b, then we have always at least one c such that the derivative at that point c is equal to lambda. Means we have always a point c such that their derivative is lambda and c will lie between a and b. Okay, so we will prove this theorem in this lecture. Okay, now other version of this theorem is also tells us when f is differentiable, okay, and f dash a and f dash b has opposite sign. Okay, opposite sign means what? If f dash a is positive sign, then f dash b will be negative sign, and if f dash b have negative sign, then it has positive signs. Means we have we have without loss of generative we can tell us this is negative, so we have 0 between f dash a and f dash b. Okay, or we can say f dash b has, okay, 0 and this is f dash a. So we have always a point, so we have there exists x belonging to a comma b such that their derivative at that point is equal to 0. Okay, so we'll prove a more general form of this theorem. Okay, so now let's prove this theorem. What it says, assume we have a new function gx which is equal to fx minus lambda x. Okay, we have given that f is differentiable function, so we can see that gx is equal to fx minus lambda x is also a differentiable function. Okay, so gx is also a differentiable function and their derivative will be what? Derivative will be f dash x because it is differentiable, and lambda x, we have here x. Okay, so it will be lambda, derivative of x will be 1, so we can write it lambda a. Okay, now we have given that here f dash a is less than lambda. If we take this part, then f dash a is less than lambda. So if we took lambda in LHS, it will be f dash a minus lambda is less than 0, and this is nothing but g dash a. Here we can see it is g dash a. If we put x equal to a here, we will got this, and g dash a is less than 0 means what? G dash a is less than 0 means there exists delta greater than 0 such that we will have a point in a to a plus delta such that g of t will be less than g of a. Okay, we can see here g dash a can be written as limit h going to 0 g a plus h minus ga divided by h, and if this is less than 0 then this will be less than 0. Okay, and but in a to a plus delta h is positive, a to a plus delta we have h is positive. Okay, so this has to be negative means g a plus h is less than g of a, so we can assume it t here, so g of t is less than g of a. Okay, so we have a point in AB such that g of t is less than g of a. So means that this is not a point of minima because g of t is less than g of a and t belongs to a comma b. Okay, so this is not a point of minima. Similarly, we have lambda is less than f dash b. So f dash b greater than, we can write it greater than lambda, and if we subtract it, f dash b minus lambda will be greater than 0. So we can similarly say there exists lambda 1 greater than 0 such that there will be point t, we can write here t1 such that put t1 belonging to b minus lambda to b. Okay, so we have another point for which value of ft1 is less than value of b. Okay, because derivative, this is nothing but g dash b is greater than 0, and similarly we can find here limit h going to 0, g of a plus h minus g of a divided by h. And since in b to b minus delta 1 h is negative, okay, and if h is negative and whole thing is positive, this means that this has to be positive, means ga plus h minus ga is greater than 0. This will imply ga plus h is greater than ga. Okay, so sorry, this is less than 0, so this has to be less than 0 and this will be less than 0. Okay, so this will be less than 0, means there is a t which is less than g of a, means g of t 1 is less than g of a. Okay, because this will be less than and this will be less than, then their ratio will be positive. Okay, so we can say here neither fa and nor fb is the point of minimum, so is the minimum value. Okay, because we have a t such that g of t, okay, we can have ga and gb. Here gb is not a point of minimum, so there will be, and gc is minimum. Okay, so neither ga neither gb is minimum value of f. So we have a point c in ab such that gc is minimum, because if f is continuous, then minimum in ab, then minimum or maximum, either we can say as that infimum and supremum is attained in AB. Okay, it is continuous, then this theorem holds. Okay, we will prove this theorem in any next lecture. Okay, if g dash c equal to 0, so f dash c minus lambda equal to 0, because g of x equal to f of x minus lambda x we have assumed. So here it will be f dash c minus lambda equal to 0, because g dash c equal to 0 by assumptions. This will imply here f dash c equal to 0. This is wrong. F dash c equal to, sorry, lambda. Okay, so we have a point in a comma b such that their f dash c equal to lambda. Okay, so if you have any queries, please ask in the comment box, and also subscribe my channel. Okay, it will be helpful for me.